Welcome, everyone. I'm excited to be here with you today. We're going to dive into the Grade 1 Wastewater Operator Certification Exam Review. This presentation is a comprehensive study guide designed to cover all the essential topics you need to know. Throughout this session, we'll explore treatment processes, safety protocols, laboratory testing, and maintenance procedures. So let's get started and make this a productive and informative experience for all of you. Let's take a closer look at the sources and characteristics of wastewater. One common factor we see is storm events. These storms can cause debris like sand, gravel, and grit to wash into collection systems, leading to intermittent surges of solids. It's important to understand that these events can significantly impact the operation of wastewater treatment. Another key point is combined wastewater. This refers to a system where both sanitary wastewater, think of household or industrial waste, and stormwater runoff are collected together in a single pipe network. During heavy rains, this can lead to large volumes of water entering the treatment system all at once, which can challenge the system's capacity. Now, regarding solids content, wastewater generally contains about 0.1% solids. But what's really interesting is the composition of those solids. Roughly 30% are suspended solids, which are particles floating or settling in the water, and about 70% are dissolved solids, which are substances dissolved into the water. Understanding this breakdown helps us design better treatment processes and manage these variations effectively. Connecting all these points to our overall theme, recognizing the sources and nature of wastewater is crucial for developing efficient treatment strategies and ensuring the system can handle fluctuations, especially during storm events. Now, let's talk about biological indicators in treatment. When we see amoebas and free-swimming ciliates, those are usually signs of poor treatment or that the biomass is still young. This often means there are process issues that need our attention. On the other hand, when we observe stalked ciliates and rotifers, that's a very good sign. It indicates that the plant effluent is very clear, with low BOD and low suspended solids. Essentially, these are signs of excellent treatment performance. Recognizing these indicators helps us understand how well the process is functioning and whether adjustments are needed to optimize treatment. Let's take a closer look at aerobic versus anaerobic bacteria. First, we have aerobic bacteria. These organisms can only reproduce and survive in environments that contain oxygen. They're actually quite important in secondary treatment processes because they help break down organic matter using the oxygen present. On the other hand, anaerobic bacteria live only in environments where there's no free or dissolved oxygen at all. These bacteria are a bit more problematic because they can cause septic conditions, and during decomposition, they produce methane gas, which is a potent greenhouse gas. Now, in the context of domestic wastewater entering natural waters, the process is quite dynamic. When wastewater first enters, aerobic bacteria quickly consume most of the oxygen, depleting it. Once the oxygen runs out, anaerobic bacteria take over, and this shift leads to the production of gases like hydrogen sulfide and methane. This transition is important because it impacts water quality and the smell, and understanding it helps us manage and treat wastewater more effectively. Now, let's take a closer look at some of the key laboratory tests we use to evaluate wastewater. First up is the BOD test, which stands for biochemical oxygen demand. This test typically takes about 5 days to complete, so it's not instant, but it gives us valuable insight into how much oxygen the microorganisms in the water will consume over time. It's also important to remember that preserved samples can only be stored for up to 2 days if kept in a refrigerator above freezing, at temperatures up to 4 degrees Celsius. This ensures the sample remains stable for accurate testing. Next, we have the Imhoff cone, which is a simple yet effective tool for measuring the volume of settleable solids in wastewater. These solids can tell us a lot about the treatment process's efficiency. When solids settle out quickly, it indicates that the treatment system is working well, providing us with quick feedback. Finally, immediate testing is crucial for certain parameters like pH, temperature, and dissolved oxygen. These tests need to be performed within about 15 minutes of sample collection. Why? because these parameters can change rapidly once the sample is taken, and timely testing ensures we get accurate, reliable data. All these tests are vital pieces of the puzzle in understanding and managing wastewater quality effectively. Let's take a closer look at the treatment stages overview. First, we have preliminary treatment. This is where large objects, grit, sand, and gravel are removed using bar screens and grit chambers. Think of it as the initial filter to catch the big stuff. During this stage, scum is also typically removed, which helps prepare the wastewater for the next steps. Next is primary treatment, which involves sedimentation. Here, the wastewater is held for about 2 hours, allowing gravity to settle out the heavier solids known as settlable solids. Clarifiers are used during this process to facilitate this settling. This step is crucial because it significantly reduces the load of solids before biological treatment. Then we move to secondary treatment. This is where biological processes come into play. Microorganisms break down organic matter, producing an effluent that meets strict standards. No more than 30 milligrams per liter of total suspended solids and BOD5, or 5-day biological oxygen demand. This step ensures the water is much cleaner and safer for discharge. Finally, we have disinfection. This is the last line of defense before the water is released back into the environment. Disinfectants like chlorine are used to eliminate any remaining pathogens, ensuring the water is safe and compliant with health standards. Each of these stages plays a vital role in transforming wastewater into clean water, highlighting the importance of a well-structured treatment process in protecting public health and the environment. Now, let's take a closer look at the preliminary treatment specifications. First, the manual bar screen is typically set at a 30-degree angle. This means the bars are positioned at 30 degrees to help with manual cleaning, making it easier for operators to remove debris. Moving on, the mechanical screen is designed with a steeper angle, generally between 45 and 60 degrees. This steeper angle facilitates more efficient mechanical cleaning, helping to handle larger volumes with less manual intervention. Next, we focus on the flow velocity through these screens. The ideal wastewater velocity in the screen channels is about 1.5 feet per second. Maintaining this velocity ensures effective screening without causing excessive head loss or allowing debris to settle prematurely. For grit chambers, the target velocity is around 1 foot per second, though it can range from 0.7 to 1.4 feet per second. Keeping the velocity within this range promotes optimal grit removal, preventing grit from being carried forward into subsequent treatment stages. Lastly, when considering the material collected on the screens, it's important to note that the screened material typically contains about 80% water. This high water content impacts how we handle and process the screened debris, emphasizing the need for proper dewatering methods before disposal or further treatment. These specifications are critical for ensuring efficient, reliable preliminary treatment, which is the foundation for the overall effectiveness of the wastewater treatment process. Let's take a closer look at the activated sludge process, which is really the backbone of secondary treatment. It mainly relies on bacteria to break down organic matter in the wastewater, making it cleaner and safer to discharge. Now, in the aeration tank, we have what's called the mixed liquor. This is a mixture of primary effluent and the returned activated sludge. This combination is essential because it provides the bacteria with the organic material they need to do their job effectively. The activated sludge itself is a mixture of these microorganisms and solids that we remove from the settling tank. Under normal conditions, this mixture should look dark chocolate brown, which indicates a healthy microbial population doing its work. To keep the process running smoothly, we use process control tools like the COD test, the FM ratio, and the percent volatile matter. These measurements give us immediate feedback, allowing us to make quick adjustments if needed. All of these elements are interconnected, and understanding them helps us optimize the treatment process, ensuring we meet environmental standards and protect public health. Let's talk about waste treatment ponds, starting with facultative ponds. These are the most common type of ponds used in wastewater treatment. They have a layered structure with an aerobic, or oxygen-rich, top layer and an anaerobic, or oxygen-deprived, bottom layer. This setup allows for effective treatment after primary processes, and sometimes these ponds are called polishing ponds because they help further clean the water before it's released or reused. Next, we should understand how dissolved oxygen, or dew, levels fluctuate throughout the day. Typically, dew is at its lowest point at sunrise because overnight, respiration by microorganisms consumes oxygen, but there's no photosynthesis happening to replenish it. As daylight increases, photosynthesis kicks in and oxygen levels start to rise, which is an important natural cycle in these ponds. Finally, let's touch on nuisance control, particularly mosquitoes. Mosquitoes can be a nuisance in these pond environments, but they are generally controlled quite simply. By disturbing the water surface with wind or currents, we prevent mosquitoes from laying eggs or breeding effectively. This natural disturbance helps keep mosquito populations in check without the need for chemical treatments. All these elements, how facultative ponds function, the oxygen cycle, and nuisance control, are interconnected parts of effective wastewater management, helping us maintain healthy and safe water treatment systems. Let's take a closer look at the properties of chlorine used for disinfection. First, physical properties. Liquid chlorine is actually amber in color, which is quite distinctive. When it turns into gas, it's about 2.5 times heavier than air, so it tends to settle in low-lying areas, creating potential safety hazards. That's something we need to be aware of during handling and storage. Moving on to free available chlorine. This is the active form that does the disinfecting work. It includes dissolved chlorine gas, hypochlorous acid, and hypochlorite ion. These are the key compounds responsible for killing bacteria and viruses, which ties directly into our overall goal of effective water disinfection. Now, safety is paramount when working with chlorine. Chlorine cylinders are equipped with a fusible plug that melts at around 160 degrees Fahrenheit. This acts as a safety feature to prevent cylinder rupture from excessive pressure. But remember, chlorine gas is extremely irritating. It can cause serious eye and respiratory issues. So, always use proper protective equipment and ensure good ventilation when handling chlorine to keep everyone safe. Now, let's take a closer look at some of the common solids treatment methods used in wastewater management. First up is anaerobic digestion. This process occurs in sealed units, where solids are broken down without oxygen, producing methane gas. This gas can actually be utilized within the plant for energy, making the process quite efficient. Typically, solids stay in these digesters for about 20 days to ensure proper breakdown. Next is composting. Here, the biosolids are subjected to controlled decomposition, which helps cure the material. Once treated, these biosolids can be safely applied to farmlands as a soil amendment, returning nutrients to the soil and supporting agricultural productivity. Then we have sand drying beds. This method relies on evaporation to remove water from the sludge. While it's a straightforward process, it does require significant labor and space, and it's weather-dependent, meaning it works best in dry, sunny conditions. Finally, mechanical dewatering involves equipment like belt filters and plate presses. These use coagulant polymers along with pressure to remove water efficiently. Vacuum filters are another option. They utilize partially submerged rotating drums for continuous operation, making the process faster and more consistent. All these methods play a crucial role in reducing the volume and improving the handling of solids, which ties back to our overall goal of sustainable and efficient wastewater treatment. Let's talk about laboratory sample holding times. It's really crucial to understand that proper sample preservation and analyzing samples in a timely manner are key to getting accurate results. If samples sit too long or aren't stored correctly, the data can become unreliable. Another important point is regarding pH meters. To ensure accurate pH measurements, the meters need to be calibrated correctly. This involves using buffer solutions that are at least 2 pH units apart, and these buffers should bracket the expected pH range of your samples. By doing this, You're making sure that your pH readings are precise and consistent, which ties back to our overall goal of obtaining reliable laboratory data. Remember, good practices in sample handling and calibration directly impact the quality of your results. Let's take a moment to talk about regulatory reporting requirements. First, some tests, like pH, temperature, and dissolved oxygen, need to be done very quickly, within just 15 minutes of collecting the sample. This quick turnaround is crucial to ensure the data we gather is accurate and relevant. Next, if there's an unusual or extraordinary discharge, or any noncompliance that could harm water quality or public health, we are required to notify the state regulatory authorities within 24 hours. Prompt reporting like this helps prevent potential environmental or health issues from escalating. Finally, it's important to keep detailed records on an ongoing basis. This means documenting all testing, maintenance activities, and any operational changes. Not only does this ensure we stay compliant with regulations, but it also helps us optimize our processes over time. In the big picture, these requirements emphasize the importance of timely, accurate, and thorough documentation to protect both the environment and public health, aligning with our overall goal of responsible water management. Let's start with voltage, also known as EMF or electromotive force. This is measured in volts and represents the electric potential difference between 2 points. It's what drives the current to flow through a circuit. Think of it as the push that makes electrons move. Next is amperage, which is the actual flow of electrons, or electrical charge, measured in amps. This is what we often refer to when talking about current. The higher the amperage, the more electrons are moving through the conductor at any given time. Then we have resistance, measured in ohms. Resistance is a material's opposition to the flow of electric current. The higher the resistance, the less current will flow for a given voltage. It's like a narrowing pipe that slows down the water, less current flows through. Finally, let's talk about protection. In electrical safety, dual-element fuses are commonly used to protect meters because they can handle different conditions. Current-limiting fuses are designed to protect against short circuits by breaking the circuit quickly when excessive current is detected. These safety devices are crucial for protecting both equipment and personnel, aligning with our overall theme of safe electrical practices. Let's go over fire safety classifications, which are essential for understanding how to respond to different types of fires. Starting with Class A fires, these involve ordinary combustibles like wood, paper, cloth, and rubber. This also includes clothing fires. When dealing with Class A fires, water or multi-purpose extinguishers are effective tools to put them out. Moving on to Class B fires, which involve flammable liquids such as oil, grease, gasoline, and solvents. Here, water is not the answer. Instead, you want to use foam or carbon dioxide extinguishers to smother the flames and prevent reignition. Next, we have Class C fires, which involve electrical equipment. The first step here is to de-energize the electrical source if possible, to prevent shock. For extinguishing, non-conductive agents like CO2 or dry chemical extinguishers are the best options, as they won't conduct electricity. Then there are Class D fires, which involve combustible metals like magnesium, titanium, and sodium. These fires require special dry powder extinguishing agents designed specifically for metal fires, because regular extinguishers won't work effectively. It's also important to note that pump stations should have a BC-type chemical extinguishers on hand. This ensures preparedness for different types of fires that might occur. And remember, for all fires, the key to extinguishing is removing one of the 3 elements: fuel, heat, or oxygen. If you can eliminate any one of these, you can effectively put out the fire. This is a fundamental concept that ties everything together and underscores the importance of choosing the right extinguishing method for each class of fire. Now, let's talk about some key safety practices for confined space entry. First, the minimum personnel required on-site includes at least 3 people. We need 1 entrant, who is actually going into the space, 1 attendant, who stays outside and keeps an eye on everything, and an entry supervisor who is responsible for signing the permit and ensuring all safety protocols are followed. Next, ventilation is absolutely critical. Before anyone enters, we have to make sure dangerous gases like hydrogen sulfide, carbon dioxide, and gasoline vapors are removed. Proper ventilation helps create a safe environment. Interestingly, carbon monoxide is less likely to accumulate in below-ground vaults, but that doesn't mean we can ignore it. Ventilation is still essential. Finally, vehicle positioning plays a big role in keeping workers safe. Whenever possible, position the vehicle between the manhole and oncoming traffic. This acts as a barrier, providing extra protection for the workers inside the confined space. All these points tie back to our overall goal: ensuring a safe, controlled environment for everyone involved in confined spacework. Let's start by talking about trench safety requirements. When working in trenches, it's crucial to follow OSHA guidelines to keep everyone safe. One key point is that if a trench is 5 feet or deeper, you need to have proper shoring or protective systems in place to prevent collapses. This is a minimum depth where protections become mandatory. Next, we have the spoil pile distance. It's important to remember that all excavated soil, or spoil, should be placed at least 2 feet away from the edge of the trench opening. Keeping the spoil pile back helps prevent accidental falls or material falling into the trench, which could cause injuries or destabilize the trench walls. Moving on to ladder spacing, every 25 feet in a trench, you need to have a ladder. This is essential for emergency egress, giving workers quick and safe access out of the trench if needed. Proper ladder placement is a simple but vital safety measure. Finally, let's look at an example scenario. Imagine a trench that's 5 feet deep with 6 workers inside. According to safety rules, you need to provide 6 ladders, 1 for each worker, to ensure everyone has a safe way to exit quickly if necessary. This highlights the importance of planning and proper equipment placement to protect our team. These are some of the key safety requirements to keep in mind when working in trenches. Staying compliant not only keeps us safe, but also helps us maintain a productive, accident-free work environment. Let's talk about health and disease prevention for wastewater workers. First, all workers must be immunized against tetanus. This is crucial because of the exposure risks from cuts and puncture wounds that can happen in contaminated environments. Staying up to date on immunizations helps protect you from serious infections. Now, regarding disease transmission, wastewater can carry and transmit several diseases like tetanus, tuberculosis, and polio. It's important to understand that these diseases can be contracted through contact with contaminated wastewater if proper precautions aren't taken. However, it's also important to note that the AIDS virus, or HIV, is not transmitted through wastewater contact. The key to staying safe is consistent proper hygiene, wearing the right protective equipment, and maintaining your immunizations. These measures are essential for protecting yourself and ensuring a safe working environment. Remember, staying informed and prepared is a vital part of managing risks in wastewater management. Let's take a closer look at some common laboratory equipment and their procedures. First, we have beakers. Beakers are primarily used for mixing chemicals and measuring approximate volumes. They are very versatile, but it's important to remember that they are not suitable for precise measurements. They're great for rough estimates and quick mixing. Next up are graduated cylinders. These are used for measuring volumes with a moderate level of accuracy. They're more precise than beakers, making them a better choice when you need a more reliable measurement, but they still don't match the precision of burettes. Speaking of burettes, these are essential when you need the most accurate measurements of liquids. Burettes are commonly used in titrations and other analytical procedures where precision is critical. Their design allows for very fine control over liquid delivery, which is key in these experiments. Finally, we have flasks. These are used for mixing, heating, and storing solutions. Volumetric flasks, in particular, provide highly accurate volume measurements, making them ideal for preparing standard solutions. Understanding the proper use of each piece of equipment helps ensure accurate results and safe lab procedures. which ties back into our overall theme of conducting reliable and precise experiments. Let's go over the key takeaways for exam success. First, mastering the numbers is essential. Make sure you're familiar with specific values like 30 mg/L-BOD5 and TSS for secondary treatment, a solids content of 0.1%, the 5-day BOD test, a fusible plug temperature of 160 degrees F, and all relevant holding times. These details are often tested, so understanding them thoroughly will give you an edge. Next, it's crucial to understand how the process relationships fit together. Think of treatment stages as building blocks. Preliminary removes large debris, primary settles out solids, secondary treatment uses biological processes, and disinfection then kills any remaining pathogens. Each stage depends on the previous one, so knowing this flow helps you see the bigger picture. Prioritizing safety cannot be overstated. Remember the confined space requirements. At least 3 people should be present, and trench safety guidelines, like maintaining a minimum of 5 feet depth and a 25-foot ladder spacing. Be aware of fire classifications and gas hazards, and know that safety questions tend to be heavily weighted on exams. Finally, understanding your organisms is vital. Bacteria are the main workers in activated sludge, doing the bulk of the treatment. Observing stocked ciliates indicates good treatment, while the presence of amoebas might suggest issues. Also, remember that aerobic bacteria need oxygen, whereas anaerobic bacteria produce methane. Connecting these biological insights back to the overall process will help you grasp how everything fits together in wastewater treatment.